statistics, and we have done descriptive statistics like quantitative. And for quantitative variable, we have measured or calculated mean, mode, median. That is the central tendency. Mode फिर categorical variable, okay? And dispersion, that is a standard deviation and interquartile range. And for categorical variable, we have calculated frequency and proportion or percentage using Jamovi software. We can use any other software. Okay, there is no problem. And today we will discuss about inferential statistics. And for inferential statistics, what we do to study the sample, and then we make inference about our population. From population, we choose sample, and from that sample, we make generalization or we make inferences about our population. So that is inferential statistics, and it is done by estimation. And in estimation, mainly it is with the confidence interval. And number two is the hypothesis testing. And there are different type of test, non-parametric, parametric. We will discuss today. So using both technique, what we are doing, we will inference our results to the population. Okay. So this is most popular slide. Yesterday we have discussed. So if we want to learn statistics, at least we have to have this knowledge about what you mean by quantitative variable and what you mean by qualitative variable. And further in quantitative, what do you mean by continuous variable, what do you mean by discrete, and in qualitative variable, binary variable, and these are the qualitative or categorical variable. Okay, so at least we should or we must have knowledge about this. Then we go for inferential statistics. Or inferential statistics, this is population, and from population, generally what we are doing, we are choosing one sample. Okay, sample of 100, 250, okay, participants. And from this sample, using hypothesis, there is a significant difference, there is a no significant difference, there is a null hypothesis, there is an alternate hypothesis. And on the basis of this sample, we are performing some test to assess the hypothesis, or these are called hypothesis testing. And on the basis of this test or hypothesis test, we reach a conclusion on the basis of this sample. And after conclusion or results, we generalize these results or conclusion to our population. So it is called inferential statistics. And how we will do, in next slide we will discuss about this, what we are doing in inferential statistics. In descriptive statistics, we are doing mean, median, mode, frequency, percentage. And in inferential statistics, we are using confidence interval of mean, median, and hypothesis testing, t-test, ANOVA test, and Mann-Whitney test, and correlation test, and chi-square test. Okay. So number one is confidence interval estimation. So for this, what we are doing, we calculate the proportion of diabetes in our sample. So yesterday I have shared one data sheet, and in that data sheet there is a diabetes yes and no. And if I want to calculate proportion, so yesterday we have calculated proportion of diabetes, percentage of diabetes. Okay, that is descriptive statistics. Today we are going to learn, we are going to do inferential statistics. And in inferential statistics, we want to estimate confidence interval of that proportion. Okay, so what we can use any statistical software like Microsoft Excel, SPSS, Stata, R, Jamovi, and whatever you want to do. Okay, and then we can calculate proportion of diabetes or any variable of categorical variable or qualitative variable, and then we can calculate 95% confidence interval. And when we get 95% confidence interval, we can interpret that we are 95% confident because we are calculating 95% confidence interval. And generally in health research, usually we are calculating 95% confidence interval. Even though we can calculate 99%, but in health research, it's our practice that we are calculating 95% confidence interval. So how can we interpret our findings? We are 95% confident that the true population prevalence of diabetes would be between this to this percentage. And this to this percentage, we are going to calculate from our data sheet, from our sample sheet. Okay. So first, this is Jamovi software. Okay, 1 minute. How to again open this Jamovi software. And after that, we have to import our data sheet in this Jamovi software. Yesterday we have done this. So what we have to do? We have to, on left side, top left side, there is a 3 lines, horizontal, small lines. We have to click this, and then we have to click open. And after open, we have to go for this, where is my data sheet? So I have to click browse. And in browse, this is our practice data sheet final. Okay, then I click this and then click open. So this sheet came here in Jamovi. So what I have to do, I have to calculate 95% confidence interval of diabetes. So for this, what I have to do, I have to click exploration, left side right corner. Okay, left side upper corner, sorry. Then I have to click this exploration, then go to descriptive here. You can see my screen. Then this will come. So what we have to do, we have to bring our diabetes from this box to variable box, and this is a horizontal arrow. Okay, and then what I have to do, I can calculate frequency table here. Then this is frequency table, percentage, proportion, but it's not giving 95% confidence interval. So what I have to do in statistics, I can calculate 95%. Okay, so this is confidence interval of mean. When we click this mean here, so what we get here, this is, okay, 1 minute. This is, you can see here, and what column, and I can shift it to row. Yes, you can see here. So what I did, this is here in descriptive, there is a variable across rows. So this is according to this adjustment. When I click on variable across column, this will give this arrangement. Okay, then I can click row, and then I can explain you here. So this is a 22 mean. Okay, mean of this diabetes, because we have given 0 and 1. Okay, so this mean is equal to this percentage you can see here. If you are giving 0 and 1, then this mean is equal to this 0.22. It is equal to 22%. Okay, and this is 95% confidence interval of this. So it is coming 0.162 to 0.278, and when we convert it into percentage, so it is coming 16.2 to 27.8. So in our slide, what we can do, we can fill here 8 is 16.2 percentage to, okay, how many? 27.8. So this is our answer. Okay. So what we can interpret using our sample, and we can like inference to or generalize to our population. We are 95% confident that the true population from which we are selecting or getting our sample, prevalence of diabetes would be between 16.2 percentage to 27.8 percentage. So we are giving inference to our population from which we have choose our sample, and from sample we have calculated prevalence of diabetes and 95% confidence interval of this diabetes in, and we can generalize our findings. Okay, this is how to do for confidence interval estimation for inferential statistics. Okay, if you want to calculate for example, if you want to calculate for this smoking, then what you have to do, you have to click smoking, you have to bring this smoking from here to here, and this is a mean means 0.52. This mean is equal to this percentage. You can see here smoking 0 and 1. 0 means no, 1 means yes. So 104 participant had smoker or our smoker. Okay, and this is percentage 52%. So this mean is equal to this percentage 52%. 0.52 means 52%, and this is 95% confidence interval. This is 45% to 59%. Okay, and then how can we generalize our finding? We are 95% confident that the true population, okay, the true population, or in the true population, the prevalence of smoking or smokers would be between 45 to 45% to 59%. It is given here. You can see. So we can generalize our finding 49% to 57% or 59%, 45 to 59%. So this is called a confidence interval estimation. Okay. Now come to hypothesis testing. So in hypothesis testing, we have a research question, and then we have null hypothesis and alternate hypothesis for that research question, and then we have p-value. Okay, and there is a like cutoff that is less than 0.05. This is our cutoff, and if we are getting p-value less than 0.05, we can reject the null hypothesis. Okay, and we can accept the, we can reject the null hypothesis H0, H0, and we can accept the alternate hypothesis if our p-value is less than 0.05. So what is our research question? Is there any association? There is some mistake. Is there any association between gender and diabetes? Okay, so in our sample, is there significant association between gender and diabetes? Okay, so for this, there is null hypothesis H0. There is no association between gender and diabetes at a significance level of 0.05. This is p-value. Okay, less than 0.05. For alternate hypothesis, there is a significant association, or there is association between gender and diabetes at a significance level of less than 0.05. So this is And what is p-value? P-value is the probability of the result is by chance, and it is like telling about a null hypothesis. So if this p-value is less than 0.05, we can reject null hypothesis and we can accept alternate hypothesis in this scenario. So we have to think about, okay, this is example of hypothesis testing. Now, for hypothesis testing or statistical test of significance, we have to some decision points. We have to have some decision points, and we have to choose these decision points. So these are the decision points to choose the test of significance. Which test we have to or we should choose to test the significance? Okay. So it is depend on type of variable. It is continuous variable or categorical variable. Okay. So we have already discussed about this. What is continuous, what is categorical. Now type of distribution, normal distribution or non-normal distribution. And I think you know very well about normal or not normal distribution is only for quantitative or continuous variable, not for categorical or qualitative variable. You have to remember this. Number of group, 2 group or more than 2 group. How many number of group? Okay. And paired or unpaired design. Okay. So paired and unpaired design, we can see here. So paired or unpaired design, pre and post blood pressure after intervention. This is paired design, pre and post. Anxiety score before and after counseling or intervention. Okay, this is paired design. We have to remember. Okay, so we have to remember these 4 things in our mind before applying or choosing any statistical test of significance. So this is second very important slide you have to remember. Okay. So we see here scale of dependent variable. These are the groups, 2 groups, 3 or more groups you can see here. 3 or more groups you can see here. 2 group. Okay. So our scale of dependent variable is continuous, and number 2 is categorical or qualitative. This is continuous means quantitative. Okay. And this categorical means qualitative. So if continuous, it means normal distribution or not normal distribution. If it is normal distribution, it is called parametric. If it is not normal distribution, it is called non-parametric. Okay. So it is in non-parametric, there is also ordinal scale or ordinal variable, mild, moderate, severe, PAN scale, PAN score. Okay. There are other score, ordinal scale. Or continuous, and continuous is not normal distributed. So if it has 2 group, like for example, control group or intervention group, there are 2 group. Male and female, there are 2 group, and these 2 group are independent sample. Okay, male different and female different. Intervention different and control different. So this is independent sample. And if it is dependent variable is a continuous variable and it is normally distributed, we should go for independent t-test, sample t-test, independent sample t-test or unpaired t-test. If this dependent variable is continuous, ordinal, and that is not normal, so we should go for Mann-Whitney U-test or Wilcoxon rank sum test. Wilcoxon rank sum test. Okay, Mann-Whitney U-test or Wilcoxon same test. Okay, so it is a synonym of this Mann-Whitney U-test. If it is categorical variable, If it is categorical variable, dependent variable is categorical variable. For example, mortality, yes and no. For example, smoker, yes and no. Diabetes, yes or no. That is a categorical variable. So if there is a two group, we have to go for chi-square test or Fisher-Exact test if there is an independent sample. Intervention and control. Intervention and control. Okay. And then there is a categorical dependent variable like mortality, yes and no. We should go for chi-square test or Fisher-Exact test. Where should we go for chi-square and where should we go for Fisher-Exact? So you just remember here, and I will show you in next slide. There is no problem. Then if there is a repeated measures like pre and post, same on same population, okay, there is baseline assessment, and after that there is an intervention, and after that there is also assessment, post intervention assessment. It is called repeated measures. If it is only two times pre and post, and if our dependent variable is continuous or normally distributed, we should go for paired sample t test or dependent sample t test. And if this our dependent variable is continuous or ordinal, that is not normal distributed, then we should go for Wilcoxon signed rank test. This is a Wilcoxon rank sum test, and this is a Wilcoxon signed rank test in repeated measures. Okay, instead of paired t test. And if our like dependent variable is categorical and there is a repeated measure before and after, then we have to go for McNemar test. Okay. Now, if we have three or more groups, for example, treatment intervention 1, intervention 2 group, and then control group. Okay, there are three group, more than two, three or more than three group. Then are okay, and dependent samples mean three groups are dependent, different. Okay, if this is continuous, dependent variable is continuous or normally distributed or parametric, then we have to go for one-way ANOVA. And if it is not normal, continuous or ordinal, then we have to go for Kruskal-Wallis instead of one-way ANOVA. And this is same chi-square or Fisher-Exact test. If there are more than two group or three or more than three group, and independent, and then dependent variable is categorical, then we can go for chi-square or Fisher-Exact test. Same as two group here, chi-square or Fisher-Exact test. So this is most important slides for the hypothesis testing or test of significance. Okay. Then this is scenario 1. Research question: is the mean age of diabetic and non-diabetic patients in our study significantly different? Means mean age of diabetic patient, mean age of non-diabetic patient, and there is a significant difference mean age of the diabetic and non-diabetic. And which statistical test to be used in this scenario? Because we know that in mean age is normally distributed. So mean age is a quantitative variable. Diabetic and non-diabetic is two group, independent two group. Okay. So which statistical test to be used in this scenario? So we have to see this slide. So we know that number 1, age is a normally distributed and it is continuous variable. Okay, so this is a continuous parametric. Okay, dependent variable is are continuous. And then there are independent samples, diabetic, non-diabetic. Or how many group? There are two group, diabetic and non-diabetic. So which test we have to use? We have to choose independent or unpaired sample t test. So we have to think before applying four scenario. I have shown you four scenario. Okay, these are the four scenario: type of variable, type of distribution, normal group, paired or unpaired design. So paired design means pre and post, up, before and after. That is paired design. Okay. So in this situation, is the mean age of diabetes and non-diabetic patient in our study sample significantly different when mean age is normally distributed. So from this table, we have to choose our dependent variable is age, and that is normally distributed, and age is a continuous variable. How many group? That is a diabetic and non-diabetic. That is an independent sample. And how many group? There are two group, diabetic, non-diabetic. So which test we have to use? We have to go for independent sample t-test. Okay. So what? So dependent, okay. So independent sample t-test, our null hypothesis will be, this is null hypothesis. You can see here, this is null hypothesis. Mean age of diabetic patient is same in the population. Diabetic, oh sorry, mean age of diabetic and non-diabetic patients. Okay, okay, is same. There is no significant difference. Okay, and that is what is HA? That is a alternative hypothesis or research hypothesis. So mean age of diabetic and non-diabetic patients are different. So this is our alternate hypothesis. 8 level of significance of 0.05. So assume dependent variable age is normally distributed. We have to variance of age at each level of independent diabetes is same. So if you are not getting what you mean by variance, variance means standard deviation square. So if these standard deviation of mean age and standard deviation of age of diabetic patient, standard deviation of age of non-diabetic patient, if these standard deviation are approximately equal, okay, approximately equal, then variance is will be equal, because what is variance? Variance is a square of the standard deviation. Subject in this study represent random sampling. They should choose from random sampling. And this is a homogeneity of variance, and we are using Leven's test. No need to worry about this, okay? So we will discuss in next slide about this. What do you mean by this, okay? So, 1 minute. So research question, is the mean age of diabetic and non-diabetic patient in the study significantly different? So we can use any statistical software, okay? SPSS, Microsoft Excel, Jamovi, whatever you have, okay? So what is our interpretation? So first we have to do this and then we can interpret. So, sorry. So this is our Jamovi, okay? Then what we can do? So t-test, for t-test in this Jamovi software, this is an exploration. In near to exploration, there is a t-test. So what we have to do? We have to click this, and this will come in independent sample t-test, paired sample t-test, one sample t-test, and we should use independent sample t-test in this given scenario. So just click this. This window will open. So our dependent variable is age. So we can bring this age from here to here. There is no problem. Okay. And then you can see here, there is some problem in this. It's not coming. Statistics is not coming. Degree of freedom is not coming, and p value is not coming. So why it's not coming for age? because you can see here in this dependent variable here, this indicate, you can see this is a scale variable. Okay, this is a scale variable or dependent, sorry, quantitative variable for continuous variable. Okay, this is a scale here. And what is it? It is three small balloon, and this is for type of a categorical variable. So for this, what we have to do, we have to convert this age variable to nominal or some categorical variable something, or to into scale variable. Okay, so how can we convert it? So what we have to do, we have to go into variable view. Okay, then we have to click this age, and then we have to go for edit button here. You can see here, and here is a measure type is nominal. Okay, this is a measure type, but age is not nominal. It is a quantitative type of. Okay, it is a scale type of variable. We can measure age. So what we have to do, we have to click this, and we have to click continuous type of variable. Yeah, ordinal, nominal, ordinal, and continuous. We know that age is a continuous type of variable. So what we have to do, we have to click this. Then it will, you can see here, it will automatically changed from three balloon to the, here you can see in balloon, in nominal there is a three balloon, small, but when we can change it continuous, because we know age is a continuous, it is automatically changed. Okay, now we can apply test here. So this is our data, you can see here, this is age. Now analysis, t-test, then independent sample t-test. This is age is converted into, you can see here in a continuous type of, then bring here. Okay, then we can perform in grouping variable. Grouping variable is diabetic and non-diabetic. You can see here diabetic and non-diabetic. You can click here, this is coming diabetic or non-diabetic, it's going on. You can see here in this table, this is t value, this is degree of freedom. Okay, and this is p value. This p value is greater than 0.05. So we can say we cannot reject null hypothesis. It means, what is our null hypothesis? Our null hypothesis is mean age of diabetic patient is same as mean age of non-diabetic patient, because our p value is 0.082, greater than 0.05. And we can again calculated mean difference, confidence interval of mean difference. We just click on effect size, confidence interval of effect size, then descriptive, what is mean in diabetic, this is a non-diabetic, and this is a mean and standard deviation, and this is diabetic 44N, and this is 28.2 mean in diabetic, and this is 8.36, this is a standard deviation. So we can see here. Okay, you can, 1 minute. And this is about, we can go for homogeneity test. This is a equal variance assumed. Okay, so this is homogeneity test. Homogeneity variance of test, Leven's test. If this p value, you can see, if this p value is a Leven's test p value is greater than 0.05, it means the variance is equal between diabetic and non-diabetic. Okay, so this is about, this is, if you want to calculate Mann-Whitney p value, you can calculate, this is a Mann-Whitney p value, you can see. Okay, because we can use Mann-Whitney if age is not normally distributed. Okay, then we can go for descriptive plots. these are the descriptive plots you can see. So this is coming, okay, mean and with median. This is a 0 means diabetic, non-diabetic, 1 means diabetic. So all the things we can get by clicking. So what we can say here, there is no statistically significant difference in the mean age between individual with and without diabetic. And what is our p value? P value is a 0. What is our p value? P value is a 0. Where is, okay, sorry, it is coming. I have to click this. 0.082. Okay, this is diabetic. 0.082. This is our p value, 0.082. So I can write down here 0.082. Okay, which is greater than 0.05. So you can do for systolic BP and assume normal distribution. Okay, and for male and female, you can do using this Jamovi software. Now, next scenario of statistical test 2. So is there a significant difference in systolic BP before and after the intervention? So it's a before and after intervention. So which statistical test to be used in this scenario? Okay. So what we have to do? We have to think about. We have to think about. So this is our systolic BP before and after the intervention. Okay, systolic BP. This is systolic BP is a continuous variable and assuming normally distributed. So systolic BP is normally distributed. So it means it is a continuous and normally distributed. That is a parametric. Normally means parametric. And it is before and after. It means it is a repeated measures before and after repetition. Okay. So it is a two groups before and after 2 times. Okay. This is a repeated measures. Then we have to use a paired t-test. If this systolic BP is not normally distributed, then we have to go for Wilcoxon signed rank test. Then we have to go for Wilcoxon signed rank test. If this P, like systolic BP is not normally distributed. Okay. Now we have to, is there a significant difference in systolic blood pressure before? That is, our variable name is SBP pre and after SBP post the intervention. So use statistical, any statistical software we can use. Then how to interpret? Okay, we have to see in a Jamovi software. So this is our Jamovi software. We can go for t-test here. Okay, we can go for t-test and this time paired t-test, paired sample t-test. Just click this. This window will open. So what we in the paired variable, what we have to insert? We have to insert systolic BP pre and systolic BP post. Then we have to see. Okay, and you can see, if you want to change this like balloon, you can change. In previous slide, I have explained you in independent t-test. Okay, so dependent t-test, if result is coming, it's okay. If not coming, you can change these. Okay, because here in paired variable, this is scale type of variable, continuous type of variable. Okay, so this is, you can see here, this is a student paired student t-test. Okay, and this is that statistic p value, this is degree of freedom, and this is p value. It is coming significant, highly significant, less than 0.001. Then what we can do? We can go for mean difference, we can go for confidence interval, we can go for effect size. Effect size is a const d. Then confidence interval, then descriptive, then this descriptive plot also. we can go for normality test, whatever we can go for. QQ plot, whatever we want, we can do. And we can also do Wilcoxon rank test, signed rank test. Okay? Wilcoxon signed rank test. This is a Wilcoxon signed rank test. If our, suppose if our systolic BP pre or systolic BP post is not normally distributed, then we can go for Wilcoxon signed rank test. And this is P value of Wilcoxon signed rank test. It is coming significant. And we can see here, this is Cohen's D. It is called effect size 1.69. It is very good effect size. Okay. And this is 95% confidence interval of this effect size. Okay. So we are 95% confidence that effect size, true population effect size between this to this, we can see. Okay. For systolic BP difference. And this is mean, this is median, this is standard deviation. We can use anything and we can make our tables. And this is normality test. You can see here Shapiro-Wilk, and we can see the p value of this test is greater than 0.05. It means this variable is normally distributed. So we can go for paired t test. No need to go Wilcoxon signed rank test. Just paired t test. But in Jamovi, we can do both simultaneously, parallelly we can do. Okay. So this is about this is QQ plot. So it is, there are some deviation here, you can see here and here, but approximately normal distributed. This is, you can get graph also with mean and median, and you can use for your paper. Okay. Now, next is, so we can say there is a statistically significant difference in systolic blood pressure after the intervention. Okay. So this is p value less than 0.001. Now next, okay, this is for not normally. Okay, then we can go for this is t test, and there is a Mann-Whitney test, then we can use this. Okay, so this is example of is the pre-intervention anxiety level, only pre-intervention anxiety level. Assume this is a not normally distributed, significantly different between male and female, because pre-intervention anxiety level or score is a score, it is a continuous type of, and this is not normally distributed. We can assume it. Okay, and male and female is two independent samples. So which test we can use? We have to go for this. Okay. So this is our dependent variable is not normally distributed, continuous or ordinal. Okay. Then there is how many groups? There are two groups, and this is independent samples, male and female. So we have to go for Mann-Whitney test or Wilcoxon sum rank test, rank sum test. Okay, both are same, and we can go for Jamovi, and in Jamovi we can choose t test. In t test there is a Mann-Whitney test. Then we can use that. Okay, so no need to go for. Then this is again scenario. Okay, 1 minute. This is for Wilcoxon signed rank test. Okay, 1 minute. Yes. So is there a research question? Is there a significant change in anxiety score before and after counseling? Assuming anxiety score before or after is not normally distributed. So if it is not normally distributed, we have to go for non-parametric test, and it is like before and after condition. Okay, repeated measures, before and after means repeated measures 2 times. Then we have to go for, this is ordinal scale or non-parametric or not normally distributed, 2 groups and 2 times. 2 groups means 2 times. before and after here. And this is repeated measures. Then we have to go for Wilcoxon signed rank test. And how can we can use it? We can do using PAD-D test in Jamovi, and there is a Wilcoxon signed rank test. Then we can go for. Okay, we can use that p value. So this is interpretation we can do. Number two, this is ANOVA. Okay, so is the systolic BP assume normally distribution, pre or post, whatever, different across occupations? Okay, is the systolic BP different across occupations? And we know occupation has four category. Okay, and four category. It means there is a more than two group, three or more than more group, three or more group. Okay, so which test we can use? So we have to see this. It is most popular slide. So our systolic BP is continuous or assuming it's normally distributed. So we can say our dependent variable is continuous or parametric or normally distributed. This is a three or more group. Occupation, four group, say three or more group. Then we can go for one way, and it is an independent group, independent samples. Okay, then we can go for one way ANOVA. So how to go one way ANOVA in Jamovi? Okay, I'll give you demo. There is no problem. So this is ANOVA test. You can see here. This is ANOVA in Jamovi. So just click. Jamovi is very, and this is a one-way ANOVA. Okay. Then we can click this one-way ANOVA. Jamovi is very, very easy software. This is a dependent variable. This is a systolic. Okay. Post. Okay. Post. Systolic BP post. We can bring here in dependent variable. Grouping variable is occupation. And please remember these like occupation or categorical variable must be coded. Okay. So grouping variable. Then we can go. This is ANOVA value. You can see here P value. This is ANOVA. F value is ANOVA value. Okay. This is a degree of freedom between, and this is within. Okay. Within group. This is a between group. This is a within group. And this is P value. P value is 0.497. It means greater than 0.05. So what we can say? We can say systolic BP after intervention or post systolic BP is not statistically different across the occupation. We can like conclude or interpret according to this. Then we can get descriptive table. We can like go for descriptive plots. We can go for homogeneity test. Homogeneity P value is again, this is greater than. It means the variance among the groups are equal. Okay, variance of dependent variable. What is dependent variable? Systolic BP are equal among the groups. There are four groups. This is a mean and SD. This is P value. This is ANOVA value. This is degree of freedom between group. This is degree of freedom within group. And this is like a homogeneity of variance. So homogeneity means variance are equal. You can see. Okay. This is plot. You can see here. This is a plot. Okay. And if we go for post hoc test, then we can go for mainly Tucky for equal variance, because here is a equal variance. This test we can see there is a homogeneity of variance is equal. Then we can go for post hoc test. Then you can see here this is a post hoc test. Please see this. If this P value is coming significant, ANOVA P value is coming significant, so we can conclude there is a significant difference between at least two groups of occupation. Two occupation. Okay? There is a significant difference. If this P value is less than 0.05, then how can we conclude there is a significant difference, mean difference of systolic BP at least between two group of occupation. But which two group we cannot tell using this p value. So for this we have to use this Tucky test, post hoc test. Okay, and this is we can see here. This is group 1 of occupation. This is group 1 of occupation, and this is group 2 of occupation. And this is p value between group 1 and group 2. This is p value between group 1 and 3. And this is p value of group 1 and group 4. In this case, this p value is not significant. So this p, all these p value are not coming significant, you can see. But if this p value is coming significant, this p value, ANOVA p value, then we have to use this post hoc test, Tucky test, exactly between which group, both group, this is coming significant. It may be between 1 and 2, it may be between 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4. So we have to see this and we have to write in our paper. Okay, so this is about ANOVA. Then, okay, now we can go for, if it is not normally distributed, we can go for like Kruskal-Wallis test. Okay, then I'll omit it. You have to see this slide and then we have to go for if there is a not normally distributed. Now, this is most popular. Is there an association between diabetes and smoking status? So we know diabetes is categorical variable, yes and no. And smoking is also categorical variable, yes and no. Okay. So which test we can use? So we have to go for this. We have to see this. So our dependent variable is continuous, ordinal or categorical. Our dependent variable is categorical. Okay. And our independent variable is a two group. So which test we have to use? And this is an independent sample. Okay. Smoking, non-smoking, independent. Pre and post, that is a repeated measures. But smoking, yes, smoking, no, independent. Diabetic, yes, diabetic, no, independent. Male, female, independent. Intervention, control, independent. Okay. Then we have to go for chi-square. If there is more than two categories, then we can go for chi-square. There is no problem. Okay. So how can we do? We have to open this Jamovi software. Then we have to go for, okay, here frequency, we have to go for frequency. Then we have to go for two outcome binomial test. Okay, and then this is independent sample contingency table. Okay, independent sample chi-square test of association, because this is an independent sample. So what we have to do, we have to click this. This will coming. Okay, so in rows we can put diabetes. Here in column we can put smoking. Okay, so this is coming table of this, and this is p value of chi-square. It is coming 0.521. It is more than 0.05. It is not significant. So what we can say? We can say here there is no statistically significant association between diabetes status and smoking behavior, because p value is greater than 0.05, greater than 0.05, or exactly p value we can write down. Okay, there is no problem. Exact p value here. Then again we can do statistics. We have to click this statistics. We can calculate odds ratio, risk ratio, difference in proportion. Just we have to click. Okay, Then we can calculate Fisher exact. So just click Fisher exact. Okay, there is no problem. Then we can go for sales here. In sales, because there is no percentage in this contingency table, when we click on column, then we get column percentage. You can see here. If we calculate, click on row percentage, then we can calculate like row percentage also. Row percentage means 100% here. Okay. Column percentage means 100% here. Okay. This is column percentage. Then preferably we are using column percentage. Then we can go for plots also. So this is bar plot. We can go, we can use percentage. So this is excellent bar plot we can, and we can copy paste. Okay, so we can do this. Where we can use Fisher exact test, where we can use chi-square test. So we can see here, if in this contingency table, these are the cells. Okay, this cell 1, cell 2, cell 3, and cell 4. If in any cell, if we have less than 5 here, figure is less than 5, then we can use less than 5, then we can use Fisher exact test. Or our sample size is less than 20, then we can use a chi-square test. But in this condition, are like in every cell or each cell, the frequency is more than 5 and total sample size is 200, that is a greater than 20. Then we can go for chi-square test. Otherwise, we can go for Fisher exact test. Otherwise, we can go for Fisher exact test. Okay. So, and this is like difference, proportion difference. This is a odds ratio and 95% confidence interval of odds ratio. And this is a graph. Then we can go for, we can do according to this. And if I want to calculate diabetes among group, okay, then I can put group column in column group. Then we can calculate diabetes among intervention and control group. You can see here, this is a group 1 and 2. This is 0 and 1, diabetes yes, diabetes no. This is chi-square p value. Okay, there is none of like cell have less than 5. Then we can total sample size 200. Then we can go for chi-square test. It is not coming significant. And this is a odds ratio, something like that. And this is a graph we can choose. Okay. Now this is last one, correlation. Okay. So correlation, where we are using correlation, when we have our dependent variable and independent variable, both are continuous. Dependent variable and independent variable, both are continuous. Okay. So it is measured by correlation coefficient R, and graphically we are presenting with help of the scatter plot. And strength is represented by R. Range from 0 means no correlation, 1 means strong correlation. And direction means negative and positive. What do you mean by positive? Positive means if one variable is increasing, second variable is also increasing. Negative means if one variable is increasing, second variable is decreasing. So this is called correlation. Okay. Is there any correlation between age of individual and their systolic blood pressure pre and post? Assume variable are continuous, normally distributed. Okay. So we know that age and systolic blood pressure both are continuous. Normally distributed, then we have to go for Pearson correlation coefficient. If it is not normally distributed, we have to go for Spearman rank correlation coefficient. If it is normally distributed, both variables are normally distributed, then we have to go for Pearson correlation coefficient. If any variable is not normally distributed, we have to go for Spearman correlation coefficient. Okay, then we have to go for Jamovi software. This is last one. Okay, I'll show you. Then I have to go for, so this is a regression. In regression, this is a correlation matrix. Should go for correlation. Okay, matrix. Then click OK. This window will open. It is between age and systolic BP post. Okay, there is no problem. We can go, assuming both are like normally distributed. So this is age. You can see this is a correlation matrix here. Okay, so this is age and systolic BP post. This is Pearson R value. It is negative, and this is 0.036. It means very weak correlation, negative correlation, and P value is coming 0.165. It means it is not significant. Then what we can write down here? We can write down here there is a very weak negative correlation between age and systolic blood pressure. R is minus 0.036 and P value is we can write down P value 0.615. So we can interpret according to this. Then for Spearman rank correlation, there is no need to do. This is in the same, there is a Spearman, like you can see box. We have to just check it. This will coming automatically. Okay. And okay, it is coming automatically. We can calculate confidence interval. We can, okay, there is no problem. Confidence interval of R. Okay. So this is Spearman row here. This is also coming weak negative correlation coefficient, and P value is coming this 0.052. But in this example, I have taken, I have taken pre-anxiety and post-anxiety score. Okay, pre-anxiety and post-anxiety. So in this, I can take pre-anxiety and post-anxiety. This is pre-anxiety and this is post-anxiety. Then I can see PR because pre and post is not normally distributed. This is coming significant, perfect positive correlation. It means if pre-anxiety is increasing, post-anxiety is also increasing, and P value is less than 0.001. So what I can do, I can write there is a correlation, there is a perfect positive correlation. There is a perfect positive correlation between this and this. R value is 1.000 and P value is less than 0.001. We can conclude according to this. There is a perfect positive correlation between pre-anxiety score and their post-anxiety score. R value is this, and this relationship is statistically highly significant. P value is less than 0.001. So this is all about today's inference. Okay, if you have any question, you can ask me. Thank you very much. And starting, there is some technical glitches, unavoidable. Okay, ma'am, thank you.
Thank you, sir.
If you have any question, you can ask, no problem.
Dear participants, if you are having any query or doubt, you can ask in the chat section and you can unmute yourself as well. Participants can unmute themselves if they want to ask anything. So till then, thank you so much, sir, for the fantastic interactive statistic session. And I really appreciate the hands-on activities that you have created, a lot of scenarios and real-world nursing examples, so that which made this complex concepts more accessible to our participants. And I hope in every manner it was very fruitful class. And started something by practicing, we can learn much and more.
Yes, ma'am, yes. Because I have given practice data and Jomovi, it's free of cost. Then you can practice, and then you will get results.
Yes, definitely. Then after 10 years, we can say, yes, sir, we can do this also.
No, after 10 years. I think if you do, you after like 1 or 2 days, you can say, okay, we can do.
No, I think so for basic startup now that we are supposed to identify whether it is continuous data, categorical data,
Yes, it
independent,
is very,
dependent.
very important.
Yes,
Yes.
then coding is must to proceed with the further steps. So by learning, everyone can do it, but it needs practice actually.
Practice.
Startup
Yes,
like that.
you are
It's a
right,
kind
ma'am.
of
Yes, ma'am.
mathematics totally, I think so.
Yes.
And many of the nurses, we are from bio section, so we used to avoid mathematics. So everyone is
Okay.
having fear when it comes to
Ah,
statistics
yes, yes.
now. So whatever my students are getting their masters or even doctorate level, I have seen they used to hire some statistician to
Ah,
do all the pending research work. But I think with Jamobi software and these practice data sets, we can do the basic start by our own.
basics. Yes, ma'am.
Uh, so thank you for this fantastic and interactive session. And you made it
Thank,
live actually. It was a
thank you, ma'am.
kind of
Thank you.
workshop. We enjoyed a lot. Thank you so much, sir, for your valuable time. In near future,
Thank,
we would like to see you again.
thank you. Thank you. Thank you.
Thank you, sir. Participants can post their queries afterwards also. We can get it answered by our eminent resource persons. And I want to share one thing that many of the participants are asking about the PowerPoint presentations as these are the genuine work of the resource persons. So for your comfortable, Liti, we can do one thing. We can share the recorded session on NTI's YouTube channel and it will be available after 27th of the May. So anytime you can check out those recorded sessions and you can learn the things better way. So thank you everyone for your dedication and cooperation as well. See you tomorrow on the same time, and the topic is sampling by eminent speaker Professor Dr. Shelvin Anand from Apollo Chhattisgarh. So see you all tomorrow at 3 p.m. Stay tuned. Thank you.